Here are the answers for the day 2 bell work. Question A, convert 45.6 milliliters into kiloliters. This is a conversion question, so write down the starting value, including its label, then multiply, draw a fraction line. We want to change from milliliters into kiloliters. Think about if you know a conversion factor that changes from milliliters into kiloliters. I don't know one. But I do know how to change from milliliters into liters, and I do know how to change from liters into kiloliters. So I'm going to solve this problem with two conversion factors. In the first, changing from milliliters into liters. 1 liter has 1,000 milliliters in it. These labels cross-cancel. Then change from liters into kiloliters. 1 kiloliter has 1,000 liters in it. And these labels cross-cancel. The label that remains is kiloliters. Mentally, or on a calculator, figure out 45.6 divided by 1,000 and then divided by another 1,000. The result in scientific notation is 4.56 times 10 to the negative 5 power. This answer has 3 digits in it, and that's the correct amount because the first number in our calculation had 3 significant figures. The label is KL. Question B, convert 45 Kelvin to a temperature in Celsius. This is a temperature conversion problem, and we have a formula for this. Celsius equals Kelvin minus 273.15. Substitute 45 in place of the capital K. And then type this subtraction into a calculator. The answer is negative 228.15. We need to think about rounding our answer. This is a subtraction problem, and the rounding rule for subtraction is the same as for adding. Pay attention to the decimal digits on the answer. Because the first number, 45, has no decimal digits, our answer can have no decimal digits. We should round to just negative 228 degrees Celsius. Question C. Two measures are 45.20 grams and 37.5 grams. Find the sum. So sum means that you add together the two numbers. When adding the numbers on a calculator, the result is 82.7. For an adding problem, pay attention to the decimal digits. The first number in the calculation has 2 decimal digits. The second number has only 1 decimal digit. So the least amount of decimal digits is 1. We want our answer to have 1 decimal digit, and it does. 82.7 has that 0.7 as its decimal digit. The label is grams. Question D. 3 measures are given. We're asked to find the product. That's when you multiply them. So I'm going to use my calculator and multiply together all 3 of those numbers. The result on the calculator in scientific notation is 1.38852 times 10 to the 10th power. But how many significant figures should we actually retain in our rounded answer? This is a multiplication problem, so this time you pay attention to the number of significant figures in the numbers. The first number has 2 significant figures. The second number has 3 significant figures. The last number has only 1 significant figure, the 9, because zeros on the end of a number are not called significant. So our final answer must be rounded so it shows only 1 significant figure. Instead of saying 1.38852 times 10 to the 10th, let's just say 1 times 10 to the 10th. There's no label on this number because none of the measurements given in the problem had a label.